This is a short demonstration of the virtual testing use case for the far side simulation managed with the SCALE.sdm system. Just as a short introduction, here we have a diagram of the workflow that has to be performed for the future testing of the far side simulation or load case. In the first step, the OEM has to go through an iterative development process, which at the end delivers the result data to be given to Euro NCAP. If we change to the SDM system where the use case is actually integrated, we start with the input data, which is managed in the scale model part of the SDM system. So here I am showing the desktop client, which has a navigation bar on the left, composed of 3 windows. In the top window, we have the so-called pool versions of our project. Each pool version contains the entire project data at a specific point in time. In the second window, we have the so-called groups, which are similar to folders in a file system, which contain components and/or parameter tables. And in the third window, we have our load cases, which in the SCALE.sdm system are called run configurations. In the middle part, we have the so-called grid, which is a tabular list of the content corresponding to our selection on the left side. So for example, here I have the keyword files or the input files for the body and white group, which is selected here and which also corresponds to the selected load case or run configuration. On the right side of the client, we have several tabs containing detailed information about the current selection. So for my selected include, I can see its history with its history comments, a 3D preview, and further properties, such as who the owner is, what version it is, when it was created, and when it was last modified. Last but not least, we have a Jobs tab, where I can see the current jobs that are running. For example, a synchronization job. For the virtual testing use case, the model integrated here is integrated more or less like any model or car project. There is a specific preset for the virtual testing use case, which shows corresponding groupings for the run configurations or corresponding columns for the components that I want to see. This area here is where the user or the simulation engineer develops the model or works on the input data. As soon as the model is ready, this can be submitted to the cluster with the remote submit function. And as soon as the job on the cluster starts running, the user gets live feedback in the desktop client. Part of this job is also some post-processing, which prepares and uploads the result data back to the SDM system. So with this said, we can now continue with the result data. The SDM system also has a web client, which I'm showing right now, and which has a view for working with the result data. This is the view that we have in front of us right now. It's similar, but not identical to the view that we just saw for working with the input data. On the left side, we also have some navigation windows and some filtering options. In the middle, we again have a grid, which displays the data that's available for us. Each line corresponds to one result or one test. In our case, we only have the simulation results. Here in the lower left corner and on the right side of the screen, we have several tabs displaying detailed information or data that belongs to the selected results. One of the most important tabs is the Report tab. Here we can select different web reports. For the virtual testing use case, we have a Euro NCAP virtual testing and validation report, which is the one we see right now. If I select more simulations, this report dynamically loads the result data that's available from the simulations into the report. At the top, it displays a general overview with a legend and with overall checks as specified by Euro NCAP. If a check is not fulfilled by any of the selected simulation results, then this is highlighted here in red. Now we can continue to the further report blocks to actually see where these checks are coming from. The first block is the quality criteria specified by Euro NCAP. These are a number of values such as a ratio between the hourglass energy and the internal energy, either of the entire model or just a dummy. These values have to be underneath certain specified thresholds. There are also 115 mandatory channels specified by the Euro NCAP documentation, which are also checked here. Not only is the number checked, but also the specific curves and also 6 mandatory videos. Next, we have a block, which displays the validation of the static model parts. Most of the parts of the input model should not vary or change between the simulations. So during the submission process for each model part that has to remain static, a so-called hash is calculated. The value of the hash itself is not that important. The first selected simulation result here is used as a base for the comparison, and all of the following selected simulation results are compared to the base. If the hash for any model part from the following simulations differs from the base, then this will also be highlighted in red. For example, if we select an additional one here, we will see that there is no data available for the pedals. And we also see that the hash is different for the seat belt, which means that the input file was edited compared to the base run. So the user can either navigate manually into the input data of this particular simulation, or the user can also navigate automatically by using the add-on Show and Scale model. Okay, the next block of the report displays rating criteria. Here again, we have a list of key values that are calculated based on the curves from these simulations. And we also have threshold values specified by Euro NCAP. Based on these threshold values, the criteria of the certification is going to be provided for this model. So this report allows users to check the rating criteria. If any of the rating criteria fail to meet the requirement or are over the specified threshold, then the engineer can check the input data. Or in this case, the engineer will probably check the curves that these values are calculated from. That's why the following block allows users to navigate through the channels that are available for the selected result. So here the user can check the curves that deliver unsatisfactory rating values. The navigation tool here is also used for detecting channels. So if any mandatory channel is missing, then it will be highlighted here in red. And the last part is for mandatory videos. All of the videos are displayed here and can be played simultaneously to also qualitatively check the results of the simulation, or maybe to check why some of the result values are unsatisfactory. The main idea of this report is to offer a very quick and efficient check for the simulation engineer based on the quality and quantity criteria specified by Euro NCAP. This means that the engineer can select the 8 simulations as soon as these were done on the HPC cluster and look at the overall issues. As soon as there is no error or problem reported here, these simulations are ready for submission to Euro NCAP. This is also easily done by export. Here I can select all or only some of the selected results and submit them to the server. As soon as the result data is ready, I can download a tar file that I can then simply upload to the Euro NCAP server. I hope you enjoyed this tutorial on managing virtual testing use cases with the SCALE.sdm system.